third graders, this is chapter 19 review test on page 403. You do have a chapter 19 open book test, so this is what we would be doing in class as a review. So make sure you're going back through and finding and flipping through the pages to find the text evidence or find the answer. So here we go. 1, 2, and 3 are vocabulary. So remember, vocabulary in our math book are highlighted words. So we have equilateral, line segment, perpendicular, angle, or parallel. So the first one for number 1, and blank is formed by two rays with the same endpoint. And it tells us to go to page 384. So formed by two rays with the same endpoint. Well, line wasn't even a choice. I don't even have to look about that. Was point a choice? No, but line segment was a choice. So is straight is a part of a line and has two endpoints. That's not what I was talking about. Was ray an option? No, but angle was an option. Is formed by two rays or line segments that share an endpoint. Ooh, wait. That's what it asked, right? It asked that two rays with the same endpoint, right? That share an endpoint. So if I go back to number 1, an angle is formed by two rays with the same endpoint. Okay, so I'm going to come over here, type number 1. An angle is formed by two rays with the same endpoint. Perfect. Okay, now number 2, intersecting lines that cross to form right angles are. And actually, I'm going to go back up here and I'm going to cross off angle because I already used it. Intersecting lines. And this is to go to page 388. Right now I'm thinking parallel or perpendicular. Intersecting lines that cross to form right angles. Well, perpendiculars, intersecting lines that cross to form right angle. Where parallel never cross. So remember, they cross to form right angles, meaning that number 2 is intersecting lines that cross to form right angles are perpendicular lines. So for number 2, intersecting lines that cross to form right angles are perpendicular lines. Perfect. Okay, then number 3 is talking about a triangle with 3 equal sides. I should probably go back up here and cross off that I used perpendicular. So a triangle with 3 equal sides. It's either an equilateral, line segment, or parallel. Let's go ahead to page 393. And I have equilateral, isosceles, and scalene. And I can see an equilateral has 3 equal sides. So number 3 is a triangle. Oops, I bumped my camera. Sorry, guys. A triangle with 3 equal sides is equilateral. All right, now we're going to do numbers 4 through 20 on our review/test. Okay, so number 4, 5, and 6 are talking about angles, whether it's a right angle, an acute angle, or an obtuse. So I'm going to go ahead and I'm going to go to page 384 and 385, and I'm going to review what a right, acute, and obtuse angle is. Remember, a right angle is a perfect corner. It's a perfect square corner, where an acute angle is small. Oh, it's so cute. It's smaller than a right angle. And then you have an obtuse angle that's greater than a right angle. So taking a look, 4, 5, 6, and 7. Now number 4, does it look like it is a perfect square, like I can get a sheet of paper in there, or is it smaller than it would be an acute or an obtuse angle because it's larger? I'm thinking it's pretty large, so I'm going to write obtuse angle. Then I'm going on to number 5. Ooh, number 5, that looks like a rectangle. And I'm looking at number 5, and that looks like it's a perfect corner there. And if it's a perfect corner, that means it is a right angle. Number 6. So 4, I had a large. 5, I had a perfect. Now 6, I'm looking at that angle, and that definitely is not a perfect corner like number 5. And it's not a large one. It's actually pretty small, which means it makes it an acute angle. And then number 7, taking a look at it, is it a perfect corner? Is it larger than a right, or is it smaller? And I'm thinking it's a perfect corner, which makes it a right angle. Okay, moving on to number 8, 9, 10, and 11. This one wants us to answer a couple things. First, we have to write the number of sides, the number of angles, and then they want us to name the polygon. So I'm actually going to open up to page 390, okay, which is talking about what a polygon is. Remember, it has to be using straight line segments. It has to be closed. And then down here, like a triangle has 3 sides, 3 angles. Where quadrilaterals, 4 sides, 4 angles. Pentagon, 5 sides, 5 angles. Hexagon is 6 sides, 6 angles. And an octagon is 8 sides and 8 angles. Notice the sides and angles are the same. So for number 8, I'm going to go through, first I got to count, right? So if I'm going to count here, 1, 2, 3, 4, and 5. So I have 5 sides, right? Well, if I have 5 sides, that means there's going to be 5 angles. But then I need to go back in and look on page 390 and figure out, what would be the name? I'm looking for 5. When I look that up, it's showing it is a pentagon. Remember, I found that answer on page 390. Okay, going to number 9. Same thing, I first got to count. I'm going to go back up here. I'm going to count 1, 2, 3, 4, 5, 6, 7, and 8. So if I have 8 sides, that means I'm going to have 8 angles. And I'm going to go back to page 390, 8 sides, 8 angles. I don't remember that one. 8 sides, 8 angles. It's not a triangle, not a quadrilateral, not a pentagon, not a hexagon, but a octagon. So I need to go back here and make sure I label it. It is a octagon. Okay, then number 10. 1, 2, 3, and 4. Ooh, so 4 sides. Which means I have 4 angles. Remember 4, kind of like in a four-wheeler, right? And a lot of times people call four-wheelers a quad. So 4 sides, 4 angles is a quadrilateral. Then we have number 11. 1, 2, 3, 4, 5, and 6. So if I have 6 sides, that means I have 6 angles. Oh, 6 sides, 6 angles. Let's go back and look on page 390. 6 sides, 6 angles. Not a triangle, not a quadrilateral, not a pentagon, but a hexagon. It is a hexagon. Okay, now 12, 13, 14, 15, and 16 are talking about the sides of a triangle. So we have equilateral, isosceles, or scalene. So I'm going to go here and go a review and take a look at page 393 and take a look at what are the definitions again. So an equilateral has 3 equal sides. You can see I have green, green, green. They're all 2 centimeters. Then I have an isosceles triangle that only has 2 equal sides. So I have a 3 and a 3 are green because they're the same, but then I have a 2 centimeters that's different, so I have an orange. Now a scalene triangle, there's 0 equal sides. So 2 centimeters, 3 centimeters, and 4 centimeters. So they're all separate colors because they're all different lengths, and that's called a scalene triangle. So if I come back here and do number 12, 13, 14, 15, I kind of like to view it as coloring. So I'm going to take my blue and see I have a 3 centimeters and 3 centimeters, but I can't color 2 centimeters because that's a different one, so I'm going to color that green. Okay, so I have 2 of the same angle, or 2 of the same side, so that is going to be an isosceles triangle. Let's take a look at number 13 with my highlighter here. I have a 3 centimeters, 3 centimeters, and 3 centimeters. Now, if you can remember, if they're all the same, all sides are the same, think about the names of it. Equilateral, isosceles, or scalene. All sides are the same, so that is an equilateral triangle. Now number 14, I have a 3 centimeters, but I have a 2 centimeters, so I gotta switch my colors. And then I have a 4 centimeters, I gotta switch my color again. So none of them are the same. I have 0 equal sides. Number 0 equal sides, that is a scalene triangle. And then number 15, same thing here. Let's go back through and use our colors. I have a 3 centimeter, I have a 5 centimeter, that's going to be a different color, and then I have a 4 centimeter, and that's going to be a different color. So I have 3 sides of different length, which makes it a scalene triangle. All right, third grade. Now we're on to 16, 17, and 18, and 19. It's talking about write as many names for each quadrilateral as you can. Remember, quadrilateral are 4-sided figures, right? But there's multiple names. You can have a trapezoid, which has 2 sets of parallel sides. You have a parallelogram that has 2 pairs of parallel sides plus 2 pairs of equal sides. You have a rhombus with 2 pairs of parallel sides, but they're 4 equal sides. And then you have rectangles, which is 2 pairs of parallel sides, 2 pairs of equal sides, but 4 right angles. And then you have a square, which is 2 pairs of parallel sides, 4 equal sides, and 4 right angles. So let's go ahead and let's take a look back at number 16. What do we see here? Well, first of all, I don't see any right angles, so I definitely know it's not a rectangle and it's not a square. So looking back on the definition, is it a trapezoid, parallelogram, or rhombus? Does it only have 1 set of parallel sides, or does it have 2 pairs of parallel sides? And I'm thinking there's 2 pairs of parallel sides. So it's definitely not a trapezoid. It is a parallelogram and a rhombus. So with that, for number 16, I'm going to write parallelogram and a rhombus. And I'm going to move on to number 17. Now number 17 kind of looks like a rectangle, right? But it's kind of like leaned over. Remember, rectangle and a square has to have right angles. And I know there's no right angles there. So I definitely know it's not a rectangle or a square. Is it a trapezoid with one pair of parallel sides? I don't think so. So is it a parallelogram? Does it have two pairs of parallel sides? I think so. But is it a rhombus, just like number 16 with all equal sides? No. So number 17 is just a parallelogram. Okay, number 18. Remember, you can always pause the video or go back to any question I didn't have that you didn't understand or went too fast. Number 18. Now, I know right off that number 18 looks like a rectangle, right? Right angles, two sets of parallel sides. So I'm going to put a rectangle. But now is it a trapezoid? No, because trapezoid only has one pair of parallel sides. Is it a square? No, because a square has to have equal sides. Is it a parallelogram? Remember, a parallelogram has two pairs of parallel sides. So I think it's a rectangle and a parallelogram. Now number 19, do not get tricked by number 19. Kind of looks like a diamond, right? But if I tilt my head, it actually looks like a square, right? Okay, because does it have two? So let's go back to the definitions first. Squares, two pairs of parallel sides. Four equal sides, four right angles. So I agree that's a square, right? Now let's look at a rectangle. Two pairs of parallel sides, does it have that? Yep. Two pairs of equal sides? Yep. The top and the bottom are the same, and the sides are both the same. Does it have four right angles? Yep. So it's actually a square and a rectangle. Is it a rhombus? Does it have two pairs of parallel sides? Yep. Does it have four equal sides? Yep. Is it a parallelogram? Two pairs of parallel sides? Yep. Two pairs of equal sides? Yep. So actually, that square is going to be a square, rectangle, rhombus, and a parallelogram. Whew. It's almost all of them, but it's not a trapezoid, is it? It is not a trapezoid. So we have square, rectangle, parallelogram, and then we said it is a rhombus. So you got all those two right. Then we're going to do a problem solving. We're going to take a look at number 20. So we have a Venn diagram, right? We have the blue circle, we have the red circle. Remember where they overlap, that's what they have in common. We have quadrilaterals. Remember, quad means four. Plane figures with one or more acute angles, so angles that are less than 90 degrees. So this trapezoid that's in the middle, it's a quadrilateral because it's four-sided. And it does have one or more acute angles because I see this angle's acute and that angle's acute. Okay, so what they want to know, describe where the figure below should be in the Venn diagram. Well, is it a quadrilateral? Is it four sides? Yep. Now, does it have one or more acute angles? Let's see here. Is this acute? Yep. Is that acute? Nope. Is this one acute? Yep. Is this one? No. So it has two sides that are acute, or two angles that are acute. And it's a quadrilateral, so it's actually going to go in the part that's overlapped. So for number 20, it is, oops, sorry, I went up one, my bad. The figure should be in the area where the sets overlap. And it says explain because it is a quadrilateral and it has two acute angles. Now remember, at any point in time during this lesson, if I went too fast or you didn't get to write that problem down, pause the video or rewind the video to go back and check your work. This is a review for your Chapter 19 open book test.